Hi guys, welcome to lesson 4 where we're going to talk about the recursive formulas. And so each of the two rules that we've talked about, the types of sequences that we've talked about, arithmetic and geometric, they both have recursive rules and they both can be found on the EOC reference sheet. Okay, so let's kind of review what we know. So the explicit arithmetic rule. So this is what that looks like. So remember, this is our first term. So this is 5, and then we're adding 3 every time. So 5 plus 3 is 8, plus 3 is 11, plus 3 is 14. So we could just keep going on and on forever. Okay, so I'm going to compare it to this recursive sequence. So every recursive sequence, no matter if it's like arithmetic or geometric, it's always going to have a starting term. So it will explicitly tell you what that starting term is. So notice it tells me I'm starting at 5, and then this means previous term. And then I'm adding 3 to the previous term. So like, what's my previous term here? It's 5. So I'm going to add 3, which is 8, add 3, which is 11, add 3, which is 14. So it's the same thing. It's describing the same thing in a different way. So you need to be comfortable with both the explicit and the recursive rules for these. Okay, and so this is the actual formula. So this is what you'll see on the EOC reference sheet. So the first term is a sub 1, which we know that. And then a sub n equals this. So it literally, like, you need these two pieces for it to work. So let's kind of practice. So this means our first term is going to be -2. Sorry, that should be a 1. And then I am adding 7 to everything. So I'm going to take -2, add 7 is 5, add 7 is 12, add 7 is 19. Okay, write a recursive rule for the sequence. Okay, so let's go backwards. So I'm going to say the first thing, I'm going to say a sub 1 equals, and then I'm going to tell them what that first term is. So a sub 1 equals 3, and then and a sub n equals a sub n minus 1. So every single time it's going to look like that, every single time. And then you're going to have either like plus or minus, and then your pattern. So notice I'm adding 3 to everything. So plus 3. Okay, what would be the explicit rule for this? Okay, so let's think back to what we know before. So a sub n equals 3 plus n minus 1 times my pattern, which is 3. Okay, let's go to geometric. So geometric, notice it's going to state the first term again, and then it's going to be multiplied to the previous term. So what is my pattern? Being multiplied to the previous term. So let's see. So I know from this that I'm going to start at -3, and then I'm going to multiply by 2. Multiply by 2. And multiply by 2. So it looks like that. So we can just keep going and going if we need to. Okay, so again, this is not anything, this is not like a new sequence. It's just like a different way of describing the original sequences that we've already talked about. Okay, so write a recursive rule for the sequence. Okay, so I need to figure out, first of all, it doesn't tell me if I'm adding, subtracting, multiplying, or dividing. So first thing is find the pattern. So let's see, I'm either adding 4 or I'm multiplying by 3. So let's see. So it looks like on this one, I'm multiplying by 3. So I'm going to go back here. Let's go down. Right here. So I'm going to do this one because I'm multiplying. So I'm going to say a sub 1 equals the first term. So a sub 1 equals, in this case, 2. And then let's go back. I'm going to say a sub n equals, I need both of those, equals r times a sub n minus 1. Okay, so a sub n equals r, which is 3, times a sub n minus 1, like that. Or you can put the 3 in parentheses. It doesn't matter. either way. Okay, let's see about this one. So it looks like, am I multiplying by 2? Nope, I'm adding 11. Okay, so a sub 1 equals 11. Those are both the same. And then a sub n equals, let's go back here. So that's this one. So I'm going to say a sub n minus 1 plus my pattern. So I have a sub n minus 1 plus 11. Okay, now let's go the other way. So now we have to write an explicit rule for each recursive rule. So again, really rely on those formula sheets. So we have, so I know that this is arithmetic because of that, and I know that this one's geometric. So hopefully you can remember. So arithmetic, I'm going to say, let's see, what's the first term? 9 plus n minus 1 times 4. And again, this is just nothing new, what we've already talked about. So this is a sub n equals, let's see, 4.5 times something to the n minus 1 power. And that's going to be my pattern, so it's 3. So again, this is what we learned yesterday and last week. It's just kind of putting everything together. Okay, so again, I tried to include like, what is this going to look like on the EOC? So number 5, what is the explicit form of a sequence given that, so basically it's the same thing. So it's giving you the recursive rule and you have to put it as an explicit form. So the first thing that I notice is that this is a geometric sequence. So I know that my first term, so a sub n equals 216, and then it's going to have some pattern to the n minus 1 power. So notice that, and also something else, notice they're using G's instead of A's. That kind of messes me up too. Okay, so I'm going to find that one. Let's see, it's not that. Is it? It's not that. It is, okay, yeah, so this one, look at B and D. These are super close. So notice that you have to have that n minus 1, so it's going to be that one. Okay, so this is another EOC type question. So we have these folding tables on a cart. The table shows a relationship between the number of tables on the cart and the height of the stacked tables. So if I have like 4 tables, it's going to stack 13 inches high. Okay, so what is the recursive form of the sequence that represents a height when our first term is going to be 7? Okay, so let's see. So all of these, notice this. That doesn't eliminate anything. So I have to figure out, first of all, like, is it arithmetic or geometric? So this is where Desmos, if you want to put it into Desmos, you can. Let's see if I can find a pattern. So this is like +6, but this is +10. So I know it's not arithmetic. Let's try geometric. So remember, when in doubt, you're going to take the second term divided by the first term. So 19 divided by 13. Let's type that in our calculator. Okay, and that gives us a hideous amount. Let's see. Yeah, guys, so I just realized this. Look at this over here. Our X's are not in order. So I'm kind of glad that I did this because I feel like you would have done the same thing, or a lot of you guys would have done the same thing. A lot of you guys would have caught it. So I am totally going to put this into Desmos. I think this is really going to help us. So let's kind of use Desmos as a cheat. Okay, so honestly, at this point, I have no idea if this is arithmetic or geometric. So let's go and just kind of check it out. Oh, look, that's a 1. Let's just kind of play around, just explore, see if it is exponential. Yeah, so look at that. That is definitely not exponential, so it's going to be linear. And so notice that I'm multiplying by 2 every time. So I'm going to go ahead and this is my first term is 7, so that's kind of nice because I can just, hold on, let's go ahead and do this. And so, yes, do you see that? So that first term is 7. And so I can just easily see that I am adding 2 every time. So I know that it's going to be arithmetic because it's going to be linear, or because it's linear. So I can come over here and I can automatically get rid of this one. And notice how it gives me the pattern. So I'm adding 2 every time. So it has to be this one right here. And so notice this one, this is kind of a sneaky snake one because it really follows along with what Desmos tells you, but it's not in the recursive form pattern. So that one is really, really close, but I think that A is probably going to be our best bet. Okay, that is it, guys.